Hello, my name is Shawn Rice, representing research computing at Purdue University. We have a project called Halcyon that we would like to talk a little bit about. Under a shared campus cluster model with many research groups investing distinct amounts in annual new hardware acquisitions, management of users and resources can become very complex. This eats up a lot of staff time. And at Purdue University, the Research Computing Division set out in 2011 to design a cluster management solution to empower faculty to manage access to their own purchased resources. In its initial incarnation, the portal provided faculty, students, and research computing staff an immediate reduction in time and effort to request, provision, and manage allocations. User allocations alone was estimated at saving close to 6.7 hours of center staff time per week over the first 18 months. New storage spaces were able to reduce from a time to completion of roughly 8 days down to 1 hour within the first year of adoption of the storage system. This project initially started in 2011. As time went on, we kept adding more and more features, and these would take on other aspects of an HPC center that many times aren't necessarily talked about, but are just equally as important, such as communications with users, such as outages, news, that sort of thing, documentation especially, customer relationships, and so on. And as these features were being added, the code, as one would expect, would become increasingly more complex, more dependent upon various pieces within each other, and became far more cumbersome just to add new features or add whole sections of code, and was just becoming a difficult task in of itself to kind of manage. So around 2009, underwent a significant re-architecture of the underlying code. This re-architecture involved two major aspects. The first and foremost was centralizing a lot of the assumptions and settings that were spread out throughout the code into configuration files, settings, or even moving some of that to the database. And the second part, very labor intensive, was restructuring all of the code to be more modular and make it easier to extend. For the most part, this meant taking sections of code or logical groupings and turning them into modules that handled very specific tasks and had very specific interfaces for those tasks. We can think of this as, say, a module for news, a module for managing resources, a module for managing orders, and so on. And as we were doing this re-architecting, we focused very strongly on the ways that outside services, scripts, and so on would interact with this code. First and foremost was a REST API. Every module implements a REST API that conforms to the OpenAPI version 3 specification, and APIs can be inspected or introspected and return back their own sort of documentation as to what parameters do they accept, what does the response look like, and so on. Next up will be, for interaction, would be a message queue. We use this primarily to perform tasks such as setting permissions on a directory, creating new storage directories, and doing those sort of asynchronous tasks with various other resources. And then finally, a very robust command line utility. We have a number of commands for inspecting data, interacting with data, performing some cron-based tasks, but every single command can also be manually run with various levels of verbosity. And not just the code was paid attention to. We spent a fair amount of time scrutinizing the interfaces. The user experience and the UI associated with that was extremely important to get right, as the whole point of a lot of this is to make life easier for both our customers and staff. So we've spent a fair amount of time trying to create more easier, more logical kind of interfaces and easy to use interfaces. For example, one of the first places that we would pay attention to is in the ordering system. We've taken an approach similar to a traditional online shopping with a cart and placing in orders and so on. Most people are familiar with this these days. It's become a fairly standard aspect of lives, and so they already kind of know how to use this once they come to the system. It also means they can place orders and essentially purchase things without necessarily having to involve staff for much of the process. We try to make it as self-serve as we can. This includes things such as they can add payment accounts to an order, assign people from their business office to those payment accounts. That person in the business office will receive an email notification of this. They can log in, press approve, deny, etc., and move the order process along as far as we can get it until staff actually does have to step in to do any kind of initialization or fulfillment of that order. And then once an order actually is placed, or fulfilled rather, these allocations and all this information can be found under a resource group. Information tends to be centralized on research groups that can have multiple managers or PIs, and managers of groups can manage the access to that group and to those allocations, such as compute queues, Unix groups, storage, how they want. Again, we try to make this as self-serve as possible, where they can add users manually, or users can request to be added to a group or compute queue. The system itself includes a number of modules. First and foremost would be management of resources and allocations for those resources. And then, of course, you want people to be able to actually get those allocations, such as purchasing, ordering, a whole order and cart system. And then you need to let people know how to actually use the allocations that they've signed up for. So we have extensions for handling documentation of those resources and how to use them, as well as integrations for things such as news stories, events, and especially things such as maintenance and outage notifications. And these have deep hooks and ties into things such as resources, so that if we, say, unpublish a resource, all the documentation will automatically unpublish. And once a user has been using stuff, we would also want to track just kind of why are they using it, how are they using it, how do they get to the point where they signed up for those specific allocations. We found that a contact reports system where we can track all of the contacts that we've had with that user and kind of their journey through research computing, it has been extremely beneficial in understanding the type of research people are doing, what they need in terms of compute resources or other research resources, and helps us plan for the future on how to better serve our customers. So that has been proven to be an extremely useful addition to the site. And then the portal in general also supports just the online presence of the HPC centers, such as informational pages, menus, contact forms, and just kind of the other general utilities that any kind of HPC center might need these days, but we don't necessarily talk a whole lot about. So we try to combine it all in kind of one package. But there's still a lot of work to be done. First and foremost on our thoughts is that we would love to implement Halcyon at another organization. This will help highlight where flexibility and configuration can be introduced to better accommodate different infrastructures and HPC center setups. The existing code has been very Purdue-centric up to this point, and now that we've done a lot of work to generalize it, we would like to see what work still remains. And then, of course, there's refining the existing code, and there's obviously still a few spots that would need to be, I guess, remove some of the Purdue-specific things from it, such as wording in emails and that sort of thing, improving the performance of the code, reducing dependencies on intermodules, and just a lot of work to just continue improving the user interface and user. Thank you for listening. Feel free to email me, Shawn Rice, Zuli@purdue.edu, or Kevon Colby, KD @purdue.edu, with any questions or thoughts.